Hey guys, Jinsung here. As a person who's got 800 on SAT Math 2 times and a Superscore of 1550, I guess I know a thing or two about the SAT, especially how to solve the math section. So I thought sharing how I solve the math section by doing some practice problems could be helpful for those who are taking the SAT. Of course, going through all the problems would be too long, so I'll go over 5 problems each from both the first module and second upper module of the practice test. Note that these aren't necessarily the hard ones, but I'm also going to show you how to solve some easier problems in a faster way. We'll be reviewing practice 1 on Bluebook, so if you haven't done the test yet, I really recommend you to try it out for yourself. So let's jump right into it.
Let's go.
So let's look at Module 1 first. This is the 6th problem where they ask you the probability of selecting a red tile. Really, from these kind of problems, you have to just ignore the data that aren't relevant to what you want to get. That's kind of the strategy for these kind of problems with tables because, well, the SAT gives you a lot of tables that have a lot of irrelevant information in it. In this case, you only have to look at the color of the tile. It should be a red tile, so you just get rid of the square and pentagon, all those stuff, because you only need the total number of red tiles and the total number of total tiles. Because, as you would know, the probability of selecting a red tile here would be total of red divided by total of total colors. So, what is that number? It's 30 divided by 100. 0.3. Easy math. You just enter this and you're good to go. So problems like problem 7 are the ones where you don't really want to spend much time on. It's an easy question, so we should just skip over all the stuff that are irrelevant by looking at the last sentence where they tell you about what we need, what we want to get from this question, which is, for this problem, plausible value of total number of people in the population who support the proposed legislation. Okay, with that information, we can know that, we need the number of people who from the population support the legislation. And if you look at other numbers, 50,000 people, okay, that's the total number of population, 50K, okay, and then 35% of the people support the legislation. Okay, we have the estimated proportion of people here. Do we have an interval? Do we have a margin of error? Yes, we do. Associated margin of error of 3%. What do we need here? The number of people in the population who support the proposed legislation based on the estimate of that. So the estimated value differs plus minus 3%, which is not a lot, so we can, for these kind of problems, just get this value, 35% of the population, and then look at the closest value. If that's not in the interval, then what can be? So we just do n times 35%, 50K here, 50 times 35 is 17.5K here. Do we have something similar to that? Yes, we do. C is kind of similar. D is about like 2 times this number. A and B are just 350, 650. That they can't be the answers because, they're too small. And C. Okay, number 11. It has center O, circumference that, diameters that and that. Lengths of PS it's twice the length of arc PQ. So, we have to know QR here, right? What is QR? Well, we have to find that out. But what we can use here is that these PR and QS are the diameters, and they pass through the origin, the center. What we can infer from here is that these two have the same angles, and these two have the same angles as well. An arc length is related to the degree of the arc, and since PS and QR have the same degree as x, we can safely say that the arc length of PS and QR are the same. So PS is 2 times PQ. So this is 2. Let's write that as 2n and n, because if arc length of PQ is n, then PS would be 2n. And what else is 2n? As I said, QR and PS have the same arc length because they have the same degree of x, so we can just say that QR also is 2n, and also SR would be n as well. If you just add them all, then we can know that the circle's circumference is 6n. What is equal to 6n? It's 144 pi. And we want to get 2n. So then we just divide the both sides by 3 and get 2n here and 48 pi on the other side. So we get 2n equals 48 pi, which is the correct answer. So for these kind of problems where they ask you about the arc length, then you have to look at what degrees and what arc lengths are the same. Number 13 is also, this problem 13 is also a very good example of you don't need to read everything because it's an easy problem. So if you look at this problem, if you just look at the chart here and the answer choices, you can just immediately know that, oh, this is the kind of problem where you establish an equation. If you're short on time, you really don't have to read the text because, well, most of the time you can just plug in the numbers, time as we can see t here, dollars as n, because that's the kind of correlation that we want here. The total amount of dollars seems to be something that's dependent on the time. Let's just plug 0 here and see where we get 604. Note that any number to the power of 0 is 1. Look at A first. T is 0, this is 1, it's not 604, rejected. 1, rejected. Okay, 1 times 604 here because the power of 0 does not apply for 604, and it's just 604 times 1 here, so it's 604. Okay, that's plausible. And then for the last one, plug 0 in, 604 plus 1 goes to 1, and that times 0.004 is just 0.004. It's not this one as well, so we can just get C here. Of course, you can look at the problem itself, the text, and establish the equation by yourself, and then compare that to the answer choices. But the ones with these answer choices, well, you don't really have to do that because you can just use the number from the table and then just plug that right in to the equations below. You especially want to look at the numbers like 0, 1, and stuff like that because it makes the calculations easier. For this one, I chose 0 because, well, everything to the power of 0 is 1, and it makes the calculations easier. You can just do it on your mind. Last problem from Module 1, we're looking at number 19. Okay, triangle JKL, cosine K is that, and angle J is a right angle. So we can just draw the triangle here, with J being the right angle and K, L here. Okay, cosine K is 24 divided by 51. What does this mean? It means that the hypotenuse of this right triangle would be 51 times something. Let's call it n. And Kj is gonna be 24 times n. How do we get this? Cosine of K is Kj over KL, which is 24, 51 in this question. If Kj is 24 times n, then KL should be 51 times n. These n's can cancel each other and it becomes 24 over 51. what do we want here? We need to look at the cosine L here. Okay, what is cosine L? We all know this. C here is 51 to the power of 2 n to the power of 2. Kj is A here, which is 24 to b to the power of 2. So what do we get for that? We get 51 to 24 to n to the power of 2. And then you just put a square root over them, and then you're good to go. Of course, for the numbers, we have to use a calculator. I have an Nspire, so I'm just going to use that. But you could also use the Desmus-like calculator that is inside Bluebook. I personally prefer using it, but I don't have it right now, so I'm just using my Nspire here. Gives us a whole number, 45, so b is 45n. The cosine L should be Lj over KL, and this is cosine L here. We can just do this and get 45 divided by 51, and you just plug that number in. So I've been editing and filming at the same time, and I found out that the length of the video already reached 11 minutes, so I thought it would be too long to be in one video, so I just broke the video down into part 1 and part 2. So this video is going to be part 1, and yeah, let's see the second upper module on the second video. So if you're interested in that, check out part 2 as well. Bye.